Hello, in this video I will be importing the models and maps we generated from the previous videos into Unreal and creating the material. I'll use material attributes to create three materials for the stone, metal and moss, and then blend them together using the ID map. I'll then use the mask map to add additional detail. I'll be using textures from the Quixel Megascans library, which you can download from within Unreal using the Quixel bridge. Here I am in Unreal, ready to import those files. You can get to the contents browser from the bottom left. Down here, I have mine docked up here, so I have more space, and I've got my props folder. I'm going to right click and come here to import. Here are the FBX files. I'm going to select all of them and click open. And make sure you've got build Nanite checked. And then click import all. This might take a little while to import, they are quite high poly, so I'll leave this to import and then come back when they're finished. There are the files finished importing. Let's put them into the scene, so I'm going to select them all and then just drag them into the scene. So arrange them a little bit. So here are all the 3D models. It's my first time seeing them all processed, so let's have a quick look. We can see some of the edge damage that we've got on the sides, the moss growing on top. And we can see the detail on the metal plate. Let's just save the project. So we're going to go to File and then Save All. Next thing to do is to import the textures. So I'm going to come back to the content browser, create a textures folder, and again right click import. And this time select all of the textures. Now these are all mask textures, so I need to set the compression setting to masks. I don't want to do this one by one on each texture, so instead I'm going to select all of them, right click, come down to Asset Actions, and Edit Selection in Property Matrix. And this will bring up this table where I can change settings on multiple assets at once. So expand compression, and come to compression settings, and select masks. You can see that's just updated that sRGB checkbox, so that's applied. And I'm going to close and save all those changes. So again, File, Save All. So I have all the files imported. The next thing I need to do is to create a material for these props. So let's create a material now. Right click, create material. I'm going to call this M underscore headstone. And double click to open the material. I'm just going to dock this tab up here. I'm going to have several materials. I'm going to have a material for the stone, a material for the moss, and then a material for the metal. So I'm going to change this to use material attributes, and then create 3 make material attributes. So here's one, copy and paste that, and copy and paste that one again. And then I want to blend these 3 materials together. First of all, I'm going to build them separately, one at a time. I'm going to start with the stone material, so I'm going to attach that to the material attributes output, and come back to the content browser, to the Megascans library, and come into surfaces, where I've got a bunch of different materials and textures that I've downloaded. You can download these all from the Quixel bridge. Let's just search for material. I'm going to type cracked rock. And then you can find a material and texture that you like and download them to your project. If you search for the code they have on the screen here, then you'll find the same material that I used. I'm going to select all three of these textures and drag and drop them into the material. So I have the base color texture, a normal map, and then a packed occlusion, roughness, and displacement. I like to make parameters allow me to adjust these materials, such as changing the saturation or brightness of the base color, or to increase the intensity of the normal map. So let's create those parameters now. I'm going to hold S on the keyboard and left click in the material graph, and that will add a scalar parameter. I'm going to add 3 scalar parameters. The first one I'm going to name base color saturation. The second one I'm going to call base color contrast. And the last one, base color brightness. I also want to prefix these as well with a number. So this will just allow the parameters to be nicely ordered in the material instance. So the first one is for saturation. So I'm going to drag off from the RGB channel on the texture sample, and I'm going to add a desaturation. The default for the saturation is going to be a value of 1, and I don't want this to control the desaturation, I want it to control the saturation. So I'm going to add a 1 minus, which will invert the value so that now when I increase its value, it will increase the saturation. I'm going to then connect this to a cheap contrast. I want to select the cheap contrast RGB. And then connect the base color contrast. And finally, I'm going to add a multiply and connect the base color brightness. I want this to be a default value of 1. I also want to add some minimum and maximum values. Let's set the saturation max to 2, base color contrast to -1 and 1, and then the brightness to a max slider of 2. And I'm going to attach that to the base color. Let's move this over to give us some more room. And next, some parameters for the normal map. So I'm going to add this to a flatten normal. And add another scalar parameter, again holding S on the keyboard and left clicking in the material graph. Let's connect that to flatness. And I'm going to call this 1 normal intensity. And like the desaturation, I want to control the intensity of this normal rather than its flatness. So I'm going to invert this using a 1 minus. So now when I increase its value, it will increase the strength of the normal. And I'm going to set the default to 1 and connect that up to the normal. And then finally, I'm going to grab the RGB of the packed occlusion, roughness, and displacement. Add this to a component mask. And I just want the green channel, which is the roughness. Connect that to a multiply. And another scalar parameter. And call this 1 roughness intensity. And set that to a value of 1. I like to keep all of these parameters lined up so I can easily select them all at once. And connect that to the roughness. And if we come over to the parameters tab, we can see what the parameters will look like on the material instance. I need to create some minimum and maximum values. So I'm going to set the roughness intensity max to 2 and the normal intensity to 10. Currently these are all grouped under global. I want to give them their own custom group. So I'm going to select them all and put them into a group called 1 parameters. I'm going to hit save. come back over to the content browser, and I'm going to come back to my material, right click, and create material instance. I'm going to call this MI for material instance, headstone underscore large 01. And open up that static mesh and drag and drop that material instance onto my static mesh. Let's save that and take a look at it in the scene. So I now have this material on the headstone. So I have UV set up for the maps that I baked, but they don't work for this tiling texture. So instead I'm going to use a technique called triplanar texturing, which projects the textures in world space. And I can do that using a world aligned texture. So let's add that now, world aligned texture. If we have a look on the world aligned texture, it says texture object. This is currently a texture sample. So I'm going to right click and convert to texture object. I also want this to be a parameter so I can change the texture. So I'm going to right click on it again and click convert to parameter. And name this one base color. And attach that to the texture object. And then I can connect this XYZ texture to the desaturation. Hit save, and then take a look at that again in the scene. And now we can see it's seamlessly textured on the object. And the textures are projected in world space, so when I scale this up, the textures don't scale up, they stay the same size. So this means I can easily rescale the objects and keep a uniform texture density. Now, one issue with this is if I was to rotate this object, so let's rotate it back, we can see I start to get some texture stretching. And you can see on the side, the texture isn't aligned to the orientation of the object. So I'm just going to reset the scale and reset the rotation and come back to the material. So rather than using world position, I'm going to use local position. So I'm going to add a local position. And so let's try saving that. And take a look. There we go. Now when I rotate my object, the texture is locked to the surface. Same if I rotate it. So now the textures are projected in local space rather than world space. But if I scale it up and down, you can see the textures are scaling up with the object, which I don't want. So to counter that, I'm going to multiply this local position by the object scale. And let's connect that to world position. And now when I scale this up and down, the textures are staying the same size. Now I still have an issue. When I rotate this down, you can see I've got some stretching here. And that's because on the world aligned texture, I also have world space normal, which I need to be in local space. So I'm going to add a vertex normal world space and transform that from world space to local space. And just like I did with the local position, I want to multiply this by the object scale. And then I can attach this to the world space normal on the world aligned texture. Let's save it. And come back to the scene. And there we go, that's now staying nicely aligned. And when I scale it up, I'm going to turn off scale snapping. There we go. you can see the textures are staying the same scale. So I get a nice consistent texture density if I need to scale up these objects. So let's do the same for my other textures. I'm going to right click on the texture sample for the normal, convert to texture object, convert to parameter, call this one.normal, and do the second for my roughness, convert to texture object, convert to parameter, and name this one.ordp, which is for occlusion, roughness, and displacement. Off the occlusion, roughness, and displacement, add a world align texture, and connect up this local position to the world position, and the local normal to the world space normal. And then connect this to the component mask. And for the normal, I'm going to use the world aligned normal. But I'm going to need to make a change to this function. If I open up this function by double clicking on it, I can come all the way over to here to where we're inputting the normal. You can see here is a transform vector, much like we're using here to transform the vertex normal from world space to local space. If I was to then plug this into the normal vector on the world align normal, it's then being converted back to world space, which I don't want. So I'm just bypass that transform. I don't want to overwrite this, so I'm going to come up to File and click Save As to save this as a new function. And I'm going to come into Pegasus, into Materials, and into Functions, and call this one World Align Normal, World Space Normals. And click Save. And I can now close that, come back to my material, and I'm going to delete this world aligned normal and add my now new world aligned world space normals. And now connect up the local position to the world position, and then connect the local normals to the normal. And then I can connect this to the flattened normal. I'm going to hit save and check this out in the scene. I'm going to set this to lighting only so I can better visualize the normal map, and just double check that that's working as I scale it up and down and rotate it. That all looks like it's working correctly. Now I just need to add these texture objects to their own group. So let's select them all. And for this one, I'm going to set the group to 1 maps and hit save. I want a way of being able to increase and decrease the tiling of these textures. So I'm going to add a constant color by holding 3 and clicking in the material graph. Set this to white. Hook this up to a multiply and multiply by this 10 just to increase the initial tiling. And then add in here a multiply. Let's add another scalar parameter and call this map tiling. And I'm going to set this to a default value of 5 and connect that to the multiply. And I'm going to put this in a group called 0 common, as this is a common parameter across all the textures, and attach that to the texture size for each of the world aligned textures and world aligned normal. So now if I look here in my little preview and change its number, I can see the texture being tiled more or less. Leave it at 5. Let's just save this material now that we've made those changes. And next I'm going to add the metal material. To do that, I can actually just copy all of these nodes and paste them up here. I'm going to just rename these parameters first and prefix them with a 2. Make sure you do that for all of the maps and the parameters. And then do the groups. So selecting all the parameters, put these in a group called 2 parameters, and select all of the maps and put these in a group called 2 maps. Now if we look at the parameters, you can see I've got those nicely organized with the stone textures first, and then what will be the metal maps second. Let's find a nice metal material. Let's come to the Megascans library, into surfaces. I want a nice rusty metal because these gravestones have been outside in the wind and the rain. And here I have a rusty metal sheet texture. Again, if you search for this code, you'll find the same texture that I've been using. So I'm going to search for rusty metal. And change my base color, normal, and occlusion roughness displacement. Okay, now I need to hook up the local position and local vertex and the map tiling. So first of all, I'm going to do the tiling. So let's connect that to the texture size. Then the local position, which I'm connecting to the world position on the world line textures and normal. And then connecting the local normal space to the world space normal on the world line texture and normal on the world line normal. Just move these back down here. Now I need to blend these two materials together, the metal and the stone. So I'm going to add a material blend symbol. I'm going to hit the stone material to the base material and the metal material to the top material. And come back to the content browser. And bring in the ID map for the large headstone. I'm going to right click on this and convert it to a parameter. And call this parameter ID map. And put this into a 0 maps, as this is going to be a common map. And then connect the red channel to the alpha. And then I can connect that to the material attributes. And we can see now in the viewport I'm blending between the stone and the metal materials. Now I want to check that this is actually working on the headstone. So rather than having to save this material and check in the scene, I'm going to come to the content browser, select the large headstone, and then in the material, click this little brick-looking icon on the far right, and that will bring that headstone into the scene. It looks like I've connected these the wrong way around. So let's change these around, put the metal as the base material and the stone material as the top material. Oh, there we go, now I can see the metal material in the viewport. So now I just need to do the moss material. I can do the same. I can copy the parameters. Let's bring those down here. And rename these parameters by prefixing them with a 3. Again, make sure you do all the texture parameters as well as the scalar parameters. And then I'm going to place all of these scalar parameters in a group called 3 parameters, and all of these texture objects in a group called 3 maps. Let's search for a moss texture. Again, if you want to use the same texture as me, you can copy this code. Let's find the same normal. So let's select the normal and drag and drop that into the scene, and do the same for occlusion, roughness, and displacement. And I also need to connect up the map tiling parameter, the local position, and the local normal space. Let's add another material blend symbol. And I'm going to change around the blend order. I want this moss material to be attached as the base material. So now I have my moss added, and that's blending using the red channel on the ID map. And then let's connect this first material blend to the base material of the second material blend and attach that to the material attributes. And then I'm going to connect the blue channel to this second material blend, add that to the alpha, and then add the metal material to the top material. There we go. And now I have the moss, stone, and metal all blended together using this ID map. I want to add some extra detail to this moss because it looks a little flat at the moment. So on the base color for the moss, after the base color brightness, after this multiply, I'm going to add a fuzz shading. And I can connect the normal map to the normal input, and then I'm going to add 3 scalar parameters. Call this fuzz core. Let's prefix those with a 1 as well. 1 fuzz power. And 1 fuzz edge. So add the default value of the fuzz core to be 0.5, the fuzz power to be 5, and the fuzz edge to be 1. And I always like to set some max values. So the fuzz core, I'm going to set a max of 2, max fuzz power to be 10, and let's set the fuzz edge max to be 2 as well. And connect those up. And I'm going to put these in a group called 1 fuzz parameters. And connect that to the base color. And that gives the moss this kind of fuzzy shimmer to the edges of the moss. If I increase the fuzz core to say 1, you can see it gets darker in the kind of center areas. And if I turn the fuzz power to 0, you can see the material becomes a bit more matte. And as I increase it, you can see it kind of gets a little bit darker in the center and more fuzzy around the edges. And as I increase the fuzz edge, you can see the edge areas become sharper and brighter. So let's save that. Now the next thing to add is the mask texture that I baked. So let's come back to the contents browser, into the textures folder, and I'm going to bring in this mask texture for the large headstone. And again, convert this to a parameter. And call this mask map. And put it into 0 maps group. Now I'm going to hold 3 on the keyboard and left click in the viewport to drop down 3 constant colors. And then hold down L and add 3 lerps. Let's connect these 3 lerps together, connecting them to the A input, and then connect the 3 colors to the B input. First color is going to be for the ambient occlusion, so I'm going to make this a kind of dark dirt color. The second color is for the cavities. This will occupy a similar area to the ambient occlusion mask, but won't be quite so broad. So I'm also going to make this a kind of dark dirt color, but make it a little bit lighter. And the third color will be for the convexity mask, which runs along the edges of the model. So I'm going to make this a light grey color for kind of the worn edges of the stone. And if I bring over this mask map, I want to connect the B channel to the alpha on this first lerp, and then connect the green channel to the alpha on the second, and then the red channel to the alpha on the third lerp. And to preview this, I'm going to connect this to the base color on the stone material. So let's grab that and come up here and connect it to the base color on the stone material. And there we can see it previewed on the model. And it's a bit over the top, it's not very subtle, so I'm going to create some parameters that allow me to control the strength of these masks, as well as adding another texture which will add some breakup to these masks. So let's bring this mask map over here to give us plenty of room, and I'm going to come back to the content browser, and in my textures folder, import, and I'm going to import a texture that I created called noise masks, which I'll provide with the project files. Let's import that, and I need to set the compression setting on this texture to masks as well. Let's save that change, and then add this into the material. I'm going to want to convert this to a texture object as well, and to a parameter, and call this 0 noise masks. And I'm going to put this into the 0 maps group as well. And I'm also going to want to set this up with an world aligned texture. So I'm just bringing down that texture size parameter, the local position to world position, and the local normals to world space normal. Now let's move this back up there. And if I just take a look at this noise mask quickly, what I've got is packed in the different channels are some different noises. So I've got one in the red channel, one in the green channel, and then another in the blue channel. So I can use different noises to break up the different masks in different way. So let's add this to a component mask. And first of all, I want just the red channel. And I'm going to connect this to a power. And then take the red channel from my mask map and add that to a power as well. And I'm going to add two scalar parameters. And if you remember, the red channel was for the convexity. So I'm going to call this first parameter convexity power. And the second parameter, convexity mask power. I'm going to select both of these, set the default value to 2 and the slider max to 5, and then connect these up to the exponent input. And then combine these with a multiply. Let's give ourselves a bit more room here, because I have a few more parameters to add. So I'm going to add this to another multiply, followed by a cheap contrast, and another multiply. Let's add 3 more scalar parameters. And the first one I'm going to call convexity multiplier. The second one, convexity contrast. And the last one, convexity opacity. On the opacity, I want the max to be 1 and the default value to be 1. On the cheap contrast, I'm going to set a default value of 0.1 and a max value of 1. And then on the convexity multiplier, a default value of 2 and a max value of 20. And then connect these up. And I'm going to select all of these parameters and put them in a group called for convexity. So if we look at the parameters tab, I've got all the parameters for the maps and materials, and at the bottom here some parameters for the convexity. And then connect this up to the third lerp. And now I can just about see some convexity on the edges of this model up here. So let's come back down to these parameters and just make some adjustments to the default values. I'm going to reduce the convexity power on the mask. And as I do that, you can start to see some more of that mask coming through. If I set it to 0, then you can see it's much stronger. And what I'm also going to do is, rather than using the same map tiling for these textures, I'm going to copy this map tiling parameter and call this map tiling noise. Add another multiply. Connect up this scalar parameter and that constant color and bring that down and connect that to the texture size for the world line texture for our noise masks. And that way I can tile this noise masks independently of my tiling textures. I'm next going to increase the convexity multiplier to 2. That'll also make this stronger as well. Let's increase it to 5. There we go, that's quite strong now. That's quite strong now, so I'm going to reduce the opacity to 0.5. And let's save that material. The next step is to set up the parameters for the occlusion and the concavity. So I'm going to select all of these nodes, copy them, and paste them below. Let's move these into view and change this from convexity to concavity. And this time I want the green channel of the noise mask. So let's connect that to this power for the concavity mask power. And grab the green channel from the mask map and bring that down here and connect this to the concavity power. And bring this up and connect this to the second lerp alpha. And you can just see some of that concavity mask here running along the edges and in some of these kind of broken up areas. Let's do the same for the ambient occlusion, copy those parameters and rename them. And rename them from concavity to occlusion. I also need to put these into a group. Groups can be called for occlusion. I also need to do the same for the concavity. And grab the noise map, add a component mask, and this time I want the blue channel. Connect this to the power for the occlusion mask power, and then grab the blue channel from the mask map. And come all the way down and add this to the power on the occlusion power. And connect this to the alpha on the last lerp. This occlusion looks a little subtle, so I'm going to increase the opacity to 1. There we go, we can see this here rug along the edges. Let's reduce the mask power to 0.5. And that's adding less breakup to the occlusion mask. Now the next thing to do is to come up to the multiply for the base color of the stone and bring this all the way down to the A input on the first lerp in the chain. And now we can see those mask maps blended on top of the stone texture. That occlusion is looking a little strong, so I'm going to come down to the opacity and turn the default value to 0.5. Now I have a nice tiling texture for the stone, and then some masks to help add some extra detail and break up on the tiling texture. If I just save that and come over to the content browser and take a look at the material instance. And you can see I've got all these parameters available to me on the material instance. The last thing I want to do is add some of these convexity and cavity masks to this metal area. So in the material, I'm going to come up to the metal textures, and after the multiply for the base color, I'm going to add down 3 lerps, and then hold 3 and left click in the graph to add another color. And I'm going to set this to go a kind of dark grey. Now, I've been dragging wires and cables around all over the place, and it's getting a bit chaotic. So what I'm going to do for each of the convexity, concavity, and occlusion, just drag off this multiply and add a named reroute declaration node. I'm going to call this one convexity alpha. Let's do the same here for the concavity, and add a named reroute declaration node. This one's going to be called concavity alpha. And do the same for the occlusion. So named reroute declaration node, occlusion alpha. And now what I can do is come up to these lerps I've just added for the metal. I'm going to drag off the alpha, and you can see here I've now got at the top here a named reroutes, and I can select one of those declared reroutes. So for the first one, I want the occlusion alpha, and I'm going to connect this lerp to the A input on the second, and then this lerp to the A input on the third. On the second lerp for the alpha, I want concavity, and for the third, I want to add the convexity. I'm going to add that color to the B input on the third lerp. And connect this multiply for the metal base color to the A input. And now for the B input, I want to add the occlusion and concavity color. So if I come down here to these 3 colors, I can also create some declared reroutes for these as well. So let's drag off this concavity color and add a named reroute and call this concavity color, named reroute occlusion color. And let's come back up, add the B for the first lerp to the occlusion color, and the second lerp the concavity color. And I've added a unique color here for the metal because rather than having the kind of white highlight on the edges, I want to have a kind of darker, more metallic grey color for this metal plate on the convexity. So now let's connect this lerp to the base color for the metal material attributes. And there we go. Now we can see we've got those masks appearing on the metal plate area. I want to sharpen up the convexity mask on the metal. So after the convexity alpha, I'm going to add a cheap contrast, and then holding 1 on the keyboard, left click in the material graph to add down a constant scalar, set that to 0.5, connect that to the contrast, and connect that to the alpha on that third lerp. And that will just sharpen up the blending on the convexity on the metal area. And lastly, I want this area to appear metallic. So I'm going to add a lerp, connect this cheap contrast to the alpha, and then connect the multiply, which is coming from the roughness, to the A input, and I want the B on the lerp to be 0. If I just connect that to base color to preview what that looks like, you'll see I've got that roughness, and then blended on top, I've got that convexity alpha. So let's connect that to the roughness, and then connect that to the metallic as well. And then just connect that lerp back up to the base color. And actually, I'm going to want to connect this cheap contrast to the metallic to make those convex areas appear metallic. Let's convert these colors to parameters. I'm going to call this for metal, and come down to our other colors, convert this to a parameter as well. Call this one for convexity, convert to parameter, call this one for concavity, convert to parameter, and this final one for occlusion. And I want to just select all 4 and put these in a group called for color. Let's just double check our parameters. You can see I've got this map tiling and noise tiling currently in the global parameter group. So let's change those. This actually should actually say map tiling noise. And I'm going to put this in a group called 0 common. Let's find the other map tiling and place that in a group called 0 common. And double check our parameters. Okay, they're in their own common group. And then we've got our common maps. Fuzz parameters. The maps for our stone. The maps for the metal. And then finally the maps for the moss. And then some detail colors and parameters. So now I'm just going to save this and then create some material instances for the other headstones. So let's come back to the contents browser. I'm going to select the material instance and hit Ctrl D to duplicate it. That's going to automatically increment this material instance. So you can see it's already named that large O2. So let's duplicate that again. So we've got headstone large 1, 2, and 3. And I need to duplicate that one more time and then rename this small 0, 1. And then let's duplicate that 3 more times. So now I have headstone small 0, 1, 0, 2, 0, 3, 0, 4. And I'm going to select all of those material instances and hit enter to open them all up. And let's just undock the contents browser so I can have this up at the same time. And I just need to come through and replace these ID maps. So first of all, let's start with headstone large 0, 2 and just replace those. Large 0, 3. Small 0, 1. Small 0, 2. Small 0, 3. And then small 0, 4. And we can close all of those. Let's close these as well. And then select all of the headstones. Again, hit return to open all of those up. Again, let's just undock this contents browser so that I've got all of my Mirror Shell instances and I can apply those to these headstones. So we've got large 02, large 03, small 01, small 02, small 03, and small 04. And we can see all those materials applied here in the content browser. So let's take a look in the scene. And then we have all of the gravestones textured. And if I just open this material instance, and I can adjust the materials for the individual headstones, we'll come back to the material if I want to make global changes to all the materials. So after I finished this material and finished recording, I noticed a couple of issues with the material. If I just switch to detailed lighting, make things clearer, see I've got the same normal map applied across the entire mesh. I'm not seeing the metal or the rock normal map. And that's because if I come into my material, I was using the material layer blend simple. If I hover over it, says blends all attributes of two materials except the normal map. So it's not blending together those normal maps. So what I actually need to do is swap these for material layer blend standard. And this will blend the two materials together properly. So if I just copy and paste these next to one another and connect the first one to the second, and I can easily relink these up if I hold Control and then grab the wire. That will kind of detach it, and I can reattach it to this new material blend. So let's do that for all of those, and do that same for the second, and connect this to the output on the material, and hit save. Come back to my material. There we go. Now I can see I've got the stone normal map, got the moss normal map, and let's have a close look on the metal. Yeah, I'm seeing that rest of the metal normal map. So that's now working. And the other thing I noticed is some stretching here on the normal map. And that's because I'd accidentally connected up this XY texture as I want X, Y, and Z. So that will project in all axes. So I need to update that as well. 4 of these textures because I copied and pasted them all. And let's hit save on that. And take a look. And that's fixed that issue as well. So I just thought I'd include those fixes to get those working as they should do. And that concludes this video series. I hope you've enjoyed this video series and have a better understanding of how you can incorporate tops into your Houdini workflow. Here I have just a handful of props, but I can now easily add additional base meshes to quickly create new variations. A workflow such as this could be applied to any repetitive process in an art pipeline, automating tasks and allowing you to process a large number of inputs.